Hi, in this video I treat the logical operators. The first operator is the AND operator. What's an AND operator? To understand it, let's have a look in a circuit simulator. At this address you can find the free online circuit simulator. The web page loads automatically with an LRC circuit, let's remove it, and build our own circuit. First we need a voltage source, could be a battery, adding a switch, adding another switch, adding an LED, and every LED needs a resistor to limit the current, and I'm wiring this up. So you have a battery with plus and minus, and to light the LED, the two switches have to be enclosed. If the switch is open, that's a 0. If the switch is down, that's a 1. So one down, and the other one down, but the LED will only light up if both switches are down. That's called an AND. So in this case, two switches are open, 0, 0, that's 0, 0, 1, 0, and 1, 0 is also 0, and two switches closed equals 1. So the next operator is the OR operator. For the OR it's the same. Okay. Build an OR here. Down. That's called an OR. Okay, will it work? If both are closed, oh yeah, I think it's a loop. Let's force it. So for the OR, at least one switch has to be enclosed. Okay. At least one bit has to be 1. So the last operator is the Exclusiveor operator. And if the bits are different, it is 1, and if they are the same, it's 0. Okay, with the AND operator you can, for example, clear 1 or more bits. If you want to have only the lower 4 bits of a byte, you can do it this way. Or to check if a specific bit is set, you can do an AND. And in this case, the result is 0, so the Z flag is set. With the OR operator, you can, for example, set one or more bits. And the exclusive OR is often used in random, pseudo-random numbers, to generate pseudo-random numbers, or in cryptographic functions. Let's do an example in the simulator. To build an exclusive OR, you would need a bunch of transistors. Let's cheat a bit and use a final logic gate, XOR gate. So let's make a little place here, and that's an XOR. That's XOR gate. We need LED and resistor, a switch, another switch, and some input, voltage here, 5 volt and 5 volt, and wiring this up. And okay, I forgot to put a ground, minus here. Switches are the same, so output is 0, and if they are different, that's a 1. Fine. Let's put an AND here. Logical gate, an AND. That's an AND. An AND, that's the same circuit as here, but in a logical gate. And adding an LED here. Ground, a resistor, wiring it up, and this one up, and this one. So, what do we have here? Here we have an half adder. That's a carry flag, or if you will see it as 2 bits. That's the lowest bit, that's the highest bit. 0 and 0 is 0. 0 and 1 is 1. 0 and 1 is 1. 0 and 1 and 1 is 2. That's called an half adder. So with an exclusive OR you could build an adder. An AND. Let's do an example in the 8085 simulator. Loading the accumulator with 0.5. That's in binary 1 and 4 is 5. Doing an AND immediate with 1. So the result will be 1. Accumulator is loaded, doing an AND, with 1. Result is 1. The 0 flag is 0 because accumulator is not 0. And the parity flag is 0 because the number of 1 bits is not even. It's just 1. So here we could have set, we want to check if the lowest bit is set. And yeah, the 0 flag is not set, so the lowest bit is set. For example, if the number is 4, so the result will be 0. Result is 0, and the 0 flag is set. Parity flag is 1 because there are 0 ones. Let's do another example. Suppose we have the number 16 hex. 2 and 4, 6 and 1. And we want to clear this bit. So the rest is 1, this is 1, and this is 1. So that's F. And this is 8, and 2 is 10, and 1 is 11. 11 is B. And you have to put a 0 in front of the F because here in the assembler the hex number has to start with a number and not with a letter. So 16 is loaded, and the result will be here a 1 and a 1 here. That's 2. 1, 2. 1, 2. 0 flag is 0 because it's not 0. The accumulator is not 0. Parity flag is 1 because there are 2 ones, this and this. You can also do an AND with register. That's AND with accumulator. And then you specify the register. In this case I will use the M. But you could use register A, B, C, D, E, H, L, and of course M. Okay. No, cancel this. We have to specify the M register here. Let's load double register H. Let's take number F0. So, and in F0 I will specify here F0. So we will cut the lower 4 bits. There's only 1 left. 0 flag is 0 and parity flag is 0 because there's only 1. Okay, do it again. So this time we want only the lower bits. And we're keeping 6 here. 0 flag is 0. Parity flag is 1 because 6 is 4 and 2. That are 2 bits. We can do the same with the OR. That's OR with accumulator. So we want to set just one bit, the lowest bit. Bit is set, zero flag is not set, and the parity flag is 1, because 1 is 1 bit and 7 is 3, so there are 4 bits. Okay, and we have also the OR immediate. Okay, that's it for the OR. Okay, the last command is Exclusiveor immediate. So suppose A is 1 and here's 2. The result will be 3, because if there's a difference, the bit is set. And zero flag is not set. Parity is 1, because 3 is 2 and 1, that are 2 1 bits. This will also work with every register. And one thing we will often see is this command, Exclusiveor with the accumulator. So what will happen here? A is 1, Exclusiveor with itself, so there's no difference. The accumulator will be 0. Zero flag is 1, parity is 1. And this one is often used to clear the accumulator. So suppose you have here, I want to clear the accumulator. It needs 2 bytes, 3E00, and that's one instruction, but it takes 7 clock cycles. If you do the same with this, exclusive with the accumulator and the accumulator, so accumulator has a value. This one is set to 0. It's 1 instruction, but only 4 clock cycles, and only 1 byte is needed. So you will find this often in source code. The Z80 CPU has specific commands for setting, clearing or testing bits, not only on the accumulator, but on every data register, and memory address over HL, IX and IY. But I will show first the typical logical operator commands. Stay tuned for the Z80, or see you in the next video. Bye bye. Let's do the first example. Loading accumulator with 5. That's in binary 4 times 0 and 0, 1, 0, 1. 4 and 1 is 5. And we want to check if the lowest bit is set or not. So we're doing an AND with 0, 1. So that's only 1. The result will be 1. Accumulators loaded, doing an AND with 1. The result is 1. Zero flag is 0, because the accumulator is not 0. And the parity flag is 0, because there's only 1 bit with 1. That's not even. Okay, suppose the value is 4. We're doing the test. 4 is loaded, doing an AND, and the result will be 0. So the 0 flag is this time 1, and the parity flag is 1 because there are 0 ones, which is even. Let's do another example. Take the number 16 hexadecimal, 2 and 4 is 6, and we want to clear this bit. So it will be 1, 1, 1. So that's F, that's 15. And 8 and 2 is 10 and 1 is 11. That's B. Sixteen is loaded, adding FB to it. That's 12. Because he has cleared here the flag at the bit. 0 flag is 0 because A is not 0, and parity flag is 1 because there are 2 ones, the one here and the one here. You can do an AND also with a register. And for register you can use A, B, C, D, E, H, L, the memory address specified in HL, or the IX plus an index, or the IY plus an index. I choose IY and a negative index, loading the index register with address 00F0, and I want to cut the 4 lower bits. So accumulator is loaded, IY is set. This is IY -1, -2 at address EE, and I will specify F0, so we will I'm cutting the 4 lower bits, and the result is 1, 0 flag, 0 flag is 0, and the parity flag is 0 because there's only one bit. Start it again, and this time I want to cut the upper 4 bits. So 6 is left, 0 flag is not set, and parity flag is set because 6 is 4 and 2, that's 2 bits, 2 1 bits, and that's even. To set a bit, you can use the w.o.p.r command. For example, setting the lowest bit, and here, for example, load register D with 80. That's the highest bit, and D. (16) is loaded, or 17, and D is loaded, and setting, that's 9. Yeah, I want to do an OR here. Oh my goodness. Again, 16, adding 1, zero flag 0, parity flag is 1, because 1 is 1 bit, and 7 is 3 bits, that are together 4 bits, that's even. 80 is loaded to D, and that's 9, 7. So the sign flag is 1, because the highest bit is set, and it could be a negative number. 0 flag is 0, and the parity flag is 0 because 9 is 8 and 1, that are two 1 bits, and 7 are 3 bits, that's 4, 2 and 1. Together they are 5 bits. That's not even, that's why parity flag is 0. The next logical command is Exclusiveor. You can use it also with every register. So A is loaded, doing Exclusiveor with 2. Exclusiveor means if the bits are different, the result is 1, and if they are the same, the result is 0. So 2 and 1 are different bits, that the result will be 3. 0 flag is 0, parity flag is 1, because 2 and 1 are two 1 bits. D is loaded, doing an Exclusiveor, that will be 8, 3. 0 flag is 0, and parity flag is 0, because 8 is 1 bit, and 3 are 2 bits, together 3, that's an odd. Let me show you something. So if you want to clear the accumulator, you have the option to set the accumulator to the value 0. It will take 2 bytes. And if you launch the program, accumulator is cleared, and it was 1 instruction, and the instruction took 7 clock cycles. There's a faster way to do it. Just use Exclusiveor accumulator A. So it takes only 1 byte. It will be 0 because there's no difference. 0 is set, and it took only 4 clock cycles. So we will see this often in source codes to clear the register A. All the commands I showed here are compatible with the Intel 8080 or 8085, but the following commands are not compatible. They are specific to the Z80. So there's a command set, you specify the bit, and then you specify the register. 0 means the lowest bit, and 7 means the highest bit. So 7. There's also a command to reset the bit. For example, 0. And there's also a command to check if the bit is set. Okay, let's give it a try. Accumulator is cleared. Setting the lowest bit will be 1. setting the 7th bit, that's the highest bit, that's 8, resetting 0, and checking if the bit is set. If it's not set, the 0 flag is set to 1, and if the bit is set, 0 flag will be 0. So you specify the bit, goes from 0 until 7, and here the register can be A, B, C, D, E, H, L, memory address, IX, and also IY. Let's do one last example. Loading HL with memory address F0, specifying HL, and the last one here. So memory address is 0, setting the first bit, setting the second bit, which corresponds to 4, so 4 and 1 is 5, and resetting this bit, goes back to 1, and checking if bit is set. 0 flag is 0, so the bit is set. I hope you enjoyed the video. Thank you for watching, and see you in the next part. Bye bye.